So, with the study of all the six group radicals in the early videos, we are going to have a basic radical scheme with an entirely different concept or different approach. अभी तक हमने जो पढ़ा बेसिक रेडिकल्स की स्कीम के बारे में, वो स्कीम हमारे इंडियन यूनिवर्सिटीज में और इंडियन सिस्टम में काफी हद तक कराई जाती है, उसको हम फॉलो भी करते हैं। लेकिन क्या वो इकलौती स्कीम हो सकती है? और भी कई स्कीम हो सकती है। यहाँ हमारा उद्देश्य है कि हम एक अलग स्कीम को देखें, रेडिकल्स को किस तरीके से बांटा गया है और क्या हम उसके लिए अपनी तरफ से कोई प्रपोज कर सकते हैं। कैन वी हैव सम प्रपोजिशन, सम आइडेंटिफिकेशन, सम मेथड ऑफ एनालिसिस, सम मेथड ऑफ सेपरेशन फॉर द रेडिकल्स इफ दे आर ग्रुप्ड डिफरेंटली देन द अर्लियर। तो अब हमारा उद्देश्य ये है कि बेसिक रेडिकल्स को जो हमने अभी तक पढ़ा है, समझा है, उसको हम एक अलग नजरिए से देखें। मैं हूं सौरभ। Let's begin with our work right now. So what is the agenda of this video? Let me tell you that this video is not the only video with this approach, and there will be 4 videos altogether. So 3 more to come with the same subject. So agenda for the present slide is the classification of basic radicals. Will be elaborating various groups and will be only talking about the scheme of the analysis of first group as they say. तो हम बात करेंगे बेसिक रेडिकल्स की क्लासिफिकेशन किस प्रकार हुआ है और हम बात करेंगे कि प्रथम समूह के रेडिकल्स को किस प्रकार से एनालाइज किया जाए। यद्यपि हो सकता है कि ये पहले से मिलता जुलता हो। आने वाले 3 और वीडियो हैं जिनमें हम छठे ग्रुप तक ऑल 6 ग्रुप्स विल बी कवर्ड। सो लेट्स प्रोसीड फर्दर एंड लेट मी हैव एज अ कोट। एक बहुत सुंदर कोट लगती है मुझे, मैं आप लोगों को भी बताना चाहता हूँ। In school, we learn to think alike, but true education is to learn how to think differently. Devashish Bridha is a man who has given these lines of wisdom. So, हम एक तरीके से सोचने की आदत है, जिस प्रकार बताया जाता है, जिस प्रकार पढ़ाया जाता है, हम उसी तरीके से समझते हैं। यहाँ मेरा उद्देश्य है कि क्या एक अलग तरीके से भी हम रेडिकल्स की स्कीम को फॉलो कर सकते हैं। Let's go to the task right now. So classification of cations by acid-base method. This is what is the title of the topic of this present discussion. And the first group, that as we say, is sodium, potassium, ammonium with no group reagent and the compound solubility, that is the chloride, sulfate, hydroxides are dissolved in water. Actually अगर हम याद करें कि हमारा जीरो ग्रुप जो था उसमें सोडियम, पोटेशियम, अमोनियम था, यहाँ हम ये कह रहे हैं कि अलग स्कीम में सोडियम, पोटेशियम और अमोनियम यहाँ भी है और इनके क्लोराइड, सल्फेट और हाइड्रोक्साइड्स पानी में घुल जाते हैं। इनफैक्ट इस ग्रुप के साथ समस्या यही है कि मोस्ट ऑफ देयर सॉल्ट्स आर वाटर सॉल्युबल एंड देयरफॉर आइडेंटिफिकेशन इज बिट डिफिकल्ट एंड वी डोंट हैव एनी स्कीम टू आइडेंटिफाई। वेल देयर आर सम स्कीम्स एज यू नो वी हैव स्टडीड अर्लियर, जैसे कि हम फ्लेम टेस्ट लगा सकते हैं या कुछ पर्टिकुलर रिएजेंट्स से हम कुछ चीजों को आइडेंटिफाई कर सकते हैं। इसके बारे में हम इस वीडियो में आगे देखते हैं। जो सेकेंड ग्रुप है, इसमें जो रेडिकल्स कहे गए हैं इस ग्रुप के अनुसार वो है सिल्वर, लेड और मरकरी। मरकरी आयन जो हमने हमारे स्कीम में भी ऐसा ही है, जहां हम उसको फर्स्ट ग्रुप कहते हैं जीरो ग्रुप के बाद। यहाँ हमने सेकंड कहा, देयर इज नॉट मच चेंज। ऑफ कोर्स द ग्रुप रीजन मस्ट बी HCl, लेकिन जो प्रेसिपिटेट्स हमको मिलेंगे वो कॉरस्पॉन्डिंग क्लोराइड्स के ही मिलेंगे, क्योंकि इनके क्लोराइड्स जो है पानी में नहीं घुलते हैं और सभी की क्लोराइड जो है व्हाइट है। So this is also another way of grouping the radicals. They are highly polarizing radicals and therefore their chlorides are practically insoluble in water. Now let's proceed to next group. So now we have in our hand is the group 3 and this contains the radicals barium, strontium, calcium. Now this were the radicals in our scheme as of fused group radicals. Now they have placed it in a way we can place it in an entirely new scheme. That is the precipitating reagent must be sulfuric acid in presence of ethanol. So corresponding sulfates will be precipitated. You must think what ethanol is doing here. That's you have to apply your brain. But if you get them precipitated all, barium, strontium, calcium with dilute sulfuric acid, then corresponding sulfates, they are insoluble and they can be further analyzed. तो अब यहाँ जो तीसरा ग्रुप है वो बेरियम, स्ट्रोंटियम, कैल्शियम का है, जो हमारे यहाँ से अब अलग है, पुरानी स्कीम से अलग है। अगला ग्रुप जो है, जो यहाँ का चौथा ग्रुप है, फोर्थ ग्रुप है, दैट कंटेन्स मेनी एलिमेंट्स लाइक एल्यूमिनियम, जिंक, क्रोमियम, टिन एंड आर्सेनिक। in 2 and 4, arsenic in 3 and 5 states. Can you tell me what is the common between these regions? कुछ सोच सकते हो आप इनके बीच में क्या समानता होगी? यदि मैं एक हिंट दूं तो ये हिंट ये है कि the axis of concentrated NaOH and 3% of hydrogen peroxide. समझे कुछ आप? Yes, you are right there. These radicals have amphoteric behavior. They got an amphoteric nature. So if they are in the lower oxidation state, they can be oxidized to higher oxidation state by peroxide. And with the concentrated alkali, when you use, hydroxides are not dissolved in water, but are dissolved in excess of alkali. That means they form some complex with the alkali itself. So that's the beauty of these grouping of these radicals. Aluminium, amphoteric, zinc, chromium, tin plus 2 plus 4 or arsenic plus 3 plus 5. They also have the amphoteric behavior. And we have got the hydrogen peroxide as an oxidizing agent which can convert chromium plus 3 to higher chromate in all the radicals. We'll study them in detail later. So this is the fourth group according to the scheme. And what is the fifth group? Let's see. And the fifth group is the long list: ferrous, ferric, magnesium, manganese, bismuth, antimony, 3 and 5. What do we see common? Well, this is true that they are not amphoteric. The excess of concentrated ammonia that is enough to cause precipitation for these radicals. The hydroxides are not dissolved in water, alkali and ammonia excess. एक बात ध्यान रखें कि इनके हाइड्रोक्साइड जनरेट होते हैं लेकिन न तो वो अमोनिया में घुलते हैं और नहीं अल्कली में घुलते हैं. So इसका मतलब ये हुआ कि they are not amphoteric in nature. That's another way of grouping these radicals. So the next group, let's talk about the group radicals for sixth group. They are cobalt, nickel, cadmium, copper and mercury. We have radicals in fourth group in our scheme, and this is nickel, cobalt and zinc, manganese. Here we have cobalt, nickel, cadmium, copper and mercury plus 2. And the group reagent is ammonia. You see, can you imagine what should be the common thing between all these radicals? Do you have any guess? Any wild guess? Oh, you are right. The hydroxides are dissolved in water, caustic soda and alkaline, but they form a soluble amine complex. And you know, that could be something which can be used for the characterization and identification of these radicals. So this is another way of grouping the radicals in terms of only acids and bases. We are using either HCl or H2SO4 or you are using NaOH or ammonia. That's all. So another a very wise method of separation, identification and grouping radicals together. I hope you enjoy, and not only enjoy, you appreciate this kind of grouping of radicals as well. So let's quickly go for the analysis of first group radical that we have studied under the title of zero group radical. So I'll not going to go in quite detail of this. We'll go quickly about, because we have studied that sodium, potassium, ammonium with no group reagents that we'll take now in our analysis course. What we can do is we can have a mixture of these radicals and treat them with the alkalis. If you treat them with alkalis, you know, ammonia gas would be dissolved because ammonium ions are acidic in nature. And in the solution, you can have K ammonium ions and sodium ions. Now, ammonium ions would be lost, of course, because now they are converted into ammonia. So what we are left here with is OH minus ion. So K plus OH minus ion and sodium ion would be a thing here that should be put. And if you do the same thing with either KOH or K2CO3, you will get the same K, NaOH ions, and the ammonia gas would be evolved. And the other method, if you take NaOH and NC, sodium carbonate, we are going to again get the same gas. Ammonia gas would be released with the same thing, K plus Na plus and OH minus. So these combination would always be there, K plus Na plus and OH minus ion. Either you can have some understanding with the flame coloration, or you can simply add some reagent to identify. For example, if you have OH minus ion in the system, you get to neutralize with acetic acid. Once you do it, the OH minus ions are lost, and you have K plus and Na plus in the mixture, and it is the tartaric acid that would bring potassium hydrogen tartrate white precipitate into the mixture of potassium and sodium. That's it. And when you talk about the sodium, if you add a complex of hexanitro cobaltate sodium hexanitrocobaltate complex, you get a yellow precipitate of potassium sodium hexanitrocobaltate solution. So that's another method of separation of K plus and Na plus. So I hope we know about this, and even if we have dealt with here again the same error is there, K plus OH minus ion and Na plus. Now you can neutralize from this. You have the same combination K plus Na plus and OH minus ion, and the same thing that we have studied right now. Now we'll proceed for a different angle, and the different angle is if you have this, you have ammonia gas lost, you have 3 radicals, you add acetic acid, neutralization would take place, you have mixture of सोडियम और पोटेशियम. अब आपके पास ये दोनों का मिक्सचर है, और एक दूसरा तरीका ये है कि इस मिक्सचर में हम एंटीमनी का एक कॉम्प्लेक्स मिलाते हैं, पोटेशियम हेक्साहाइड्रोक्सो एंटीमनेट, और ये सोडियम हेक्साहाइड्रोक्सो एंटीमनेट की व्हाइट प्रेसिपिटेट देता है. और इस मिक्सचर में अगर दूसरे तरीके से हम जो हमारे नया स्पेसिफिक रिएजेंट है, दैट इज zinc uranyl octacetate triuranyl, zinc triuranyl octacetate combination that goes in yellow precipitate, or sodium zinc triuranyl octacetate. So this is something, you get a complex of this species that has been described here. The composition will be very different from this, but that's not a point here. That's a specific test for sodium in the solution. So I think this all we have studied already zero group in earlier videos. Nothing to elaborate anymore. Thanks for watching. Thanks for watching again, dear friends.